For centuries, Stonehenge has been wrapped in rumor, ritual, and raw speculation, but the newest scientific evidence is bolder than any legend. Recent lab work, field digs, and precision scans point to a stunning conclusion that rewrites who built it, how they moved it, and why it mattered. We'll ask the questions many avoid. Were these stones really dragged by ice, or by people with a master plan? Was Stonehenge a cosmic clock, a soundstage for secret rites, or both? If you're drawn to buried truths, high-stakes debates, and behind-the-scenes arguments, this is for you. Human hands, not ice. For more than a century, one of the fiercest debates around Stonehenge revolved around the origin of its smaller stones, the so-called bluestones. Were they left behind by retreating glacier, scattered like natural breadcrumbs across the Salisbury Plain? Or were they deliberately carried, hauled across nearly 150 miles of rugged land by Neolithic builders with a vision? The answer seemed out of reach, until one overlooked rock became the key that unlocked the mystery. That stone is known as the Newell boulder, discovered about 100 years ago and long dismissed as an anomaly. For decades, geologists argued about whether it was just a glacial erratic, an accidental traveler dragged south by ice sheets thousands of years ago. But when scientists recently re-examined it with cutting-edge geochemical and microscopic analysis, the results were jaw-dropping. The Newell boulder's chemical signature matched perfectly to a specific outcrop in Wales called Craig Rose-Wyfelin. Its trace elements, including thorium and zirconium, were identical, leaving no doubt about its birthplace. This wasn't a random stone dropped by ice, it was carefully chosen, cut, and transported by human hands. The discovery didn't stand alone. The same team compared fragments buried at Stonehenge, including Stone 32D, once thought to be a different rock type altogether. The analysis revealed that it wasn't dolerite as previously believed, but the same foliated rhyolite as the Newell boulder. Even more telling, its surface chemistry showed high calcium carbonate deposits from centuries underground in chalk soil, consistent with long burial after deliberate placement, not glacial scatter. Piece by piece, the evidence lined up. These bluestones weren't scattered by nature. They were moved, placed, and integrated into a monument that was being built with staggering intent. Skeptics, of course, point out the scale of the task. How could Neolithic people, with no wheels, no beasts of burden, and no metal tools, possibly transport multi-ton stones across such a distance? Yet the argument crumbles when compared to other feats they achieved. The Sarsens, the towering stones weighing more than 20 tons each, were brought from westwards about 20 miles away. Even more astonishing, the altar stone travelled nearly 470 miles from Scotland, one of the longest prehistoric transport routes ever attempted. If communities of the time could move stones of that magnitude, hauling 2 to 3 ton bluestones from Wales was not only possible, it was almost easy by comparison. We also know from ethnographic studies of other indigenous societies that long-distance transport of massive stones is achievable with simple technology: wooden sledges, ropes twisted from natural fibers, wooden rollers, and carefully prepared trackways. What seems impossible to modern eyes was, for ancient communities, a test of organization, determination, and shared purpose. It wasn't brute strength alone but coordination, villages uniting, pulling together, quite literally, to achieve something greater than themselves. And perhaps that's the real clue. If the stones were transported not by ice but by intention, then the builders weren't just erecting rocks in a field. They were encoding meaning, shaping a monument whose purpose demanded extraordinary sacrifice. Every bluestone at Stonehenge is not simply a geological block, it's a testament to deliberate planning and cultural vision. If these stones were carried with such intent, then the question becomes clear: what exactly were they building toward? The answer doesn't just lie in the ground, it shines in the sky, written in sunlight itself. Blueprint in the sun. If the bluestones prove intent, the Sarsens reveal design. These towering blocks, some weighing more than 20 tons, aren't scattered haphazardly. They form a circle so precise that archaeologists now believe it encodes something far more ambitious than simple ritual space. It's a calendar carved in stone, a perpetual machine for tracking the rhythm of the sun. At the heart of this revelation lies the Sarsen Circle, a ring of 30 massive uprights linked by horizontal lintels. Each stone, researchers argue, represents a single day. Taken together, They create a 30-day cycle that mirrors the Neolithic concept of a month. But the builders didn't stop there. Two stones, slightly different in shape, break the otherwise perfect pattern, marking the start of new weeks. And these weren't 7-day weeks as we know them today, they were 10-day segments. In this rhythm, 3 weeks made a month, and 12 months gave 360 days. Of course, that left 5 days unaccounted for. This is where the trilithon horseshoe, the iconic cluster of 5 massive uprights crowned by lintels at the center, enters the story. Each of these colossal stones represents one of those extra days, the epigomenal stretch that turns 360 into 365. For ancient people, these weren't ordinary days. They were festival markers, a sacred pause in the cycle when communities could celebrate, worship, or remember. They were moments out of time, deliberately emphasized by placing them in the very heart of the monument. But the builders went even further. Every solar year is not exactly 365 days, but about 365.25. Without correction, a calendar drifts out of sync with the seasons. And yet, evidence suggests that Stonehenge's architects accounted for this with the station stones, 4 megaliths that form a rectangle on the outer boundary of the site. Their placements hint at a leap day correction, an extra day added every 4 years to keep the entire system aligned with the sun's cycle. It implies that the builders of Stonehenge, some 4,000 years ago, were not only able to track the solar year but also were skilled enough to construct a monument able to maintain its accuracy over a number of centuries, decades if not centuries we are still talking of. The implications are much more significant than this. In a world without a written calendar, calendars were not merely records in books or scrolls, they were tangible, visible, and monumental. To embed a timekeeping system into stone means that it survived generation after generation, guiding farmers in planting or harvesting, priests in executing ceremonies, and leaders in calling forth their people. The rhythm of the year was not only about practicalities, it was also profoundly political. He who controls the calendar controls society's rhythm. Imagine a gathering at the solstice, hundreds of people coming into Salisbury Plain. Leaders stand between the stones in the center, proclaiming the beginning of a festival or the start of counting a season. The monument itself validates their words, as the sun rises or sets in perfect alignment. This wasn't just architecture, it was authority, encoded in rock and light. Stonehenge, then, is more than a pile of stones. It is a perpetual calendar, an ancient time machine, designed to bridge the cycles of the sky with the lives of people on Earth. And that kind of careful planning raises an even bigger question. If the builders aligned their stones so precisely to the sun, what else inspired their vision? A calendar this careful hints at a deeper origin story, one that begins far from Salisbury Plain.